Imagine a world where the relentless march of glaciers sculpted the landscape and volcanic eruptions blackened the skies, long before the clamor of modern industry. Picture Earth, a dynamic entity in perpetual flux, where the climate oscillated wildly over millennia, driven by forces far beyond human control. In this grand narrative, human beings are but a fleeting whisper in the storm of natural phenomena. Yet, we are told that our every breath, every car ride, and every factory exhaust is changing the very fabric of our planet. But what if this view is not the whole story? What if the seemingly irrefutable consensus that human activity is the primary driver of climate change is more a reflection of our collective anxieties than a scientific certainty? Consider the story of the Earth's climate as a vast, untamed ocean. For centuries, explorers have charted its waves and currents, driven by both passion and necessity. Now, however, we find ourselves at a crossroads, where our assumptions and models may not be as reliable as we once believed. What if the climate's turbulent nature has been misinterpreted, and our role in its transformation is less pivotal than we are led to believe? As you delve into this discussion, prepare to question the very foundations of our climate narrative. Explore the untold history of Earth's climate cycles, the enigmatic forces of the cosmos, and the limits of our scientific predictions. This journey promises to challenge your perceptions and ignite a dialogue about the true drivers of the climate's ever-changing face. Are we on the brink of a new understanding, or are we clinging to old certainties that may soon unravel? Join me as we uncover the layers of this complex debate and explore whether our impact on climate change is as significant as it seems, or merely a chapter in a much larger, natural saga. Climate change is undeniably one of the most hotly debated topics in contemporary discourse. The prevailing consensus asserts that human activities, particularly the emission of greenhouse gases, are the primary drivers of recent changes in global climate patterns. However, a closer examination reveals that this view is not without its challenges. This essay aims to explore and present the argument that human activity has little to no influence on climate change, drawing on historical climate patterns, natural climatic cycles, and the complexities of climate models. Historical climate patterns. One of the most compelling arguments against the notion that human activity significantly influences climate change is the historical record of Earth's climate. Over the course of millions of years, our planet has experienced significant climate variations, long before humans could have had any substantial impact. These include ice ages, warm periods, and drastic shifts in atmospheric composition. Natural variability. Earth's climate has always been subject to natural variability. Ice core data, tree rings, and sediment records reveal significant climate shifts that occurred long before the advent of industrial activity. For instance, the medieval warm period, approximately 900–1300 AD, and the Little Ice Age, approximately 1300–1850 AD, were significant climatic events influenced by natural factors such as solar variability and volcanic activity. Solar influence. Solar radiation is a primary driver of Earth's climate. Changes in solar energy output, known as solar cycles, have been correlated with climate variations. During periods of high solar activity, Earth tends to warm, while during low solar activity, cooling occurs. The Maunder minimum, a period of low sunspot activity from 1645 to 1715, coincided with the coldest part of the Little Ice Age, suggesting a strong link between solar output and climate. Volcanic activity. Volcanic eruptions can inject large quantities of particulate matter and sulfur dioxide into the atmosphere, leading to short-term climate cooling. The eruption of Mount Tambora in 1815, for instance, led to the year without a summer in 1816, characterized by severe global cooling. Such events demonstrate that natural phenomena can have profound impacts on the climate, independent of human activity. Natural climatic cycles. Another argument supporting the minimal role of human activity in climate change is the existence of natural climatic cycles that operate over various timescales, from decades to millennia. Milankovitch cycles. These cycles are long-term changes in Earth's orbit and axial tilt, which influence the distribution and intensity of sunlight received by the planet. Milankovitch cycles are responsible for the timing of ice ages and interglacial periods over the last million years. These cycles are driven by gravitational interactions with other planets and are entirely natural processes. Oceanic cycles. The oceans play a crucial role in regulating Earth's climate through cycles such as the El Niño Southern Oscillation, ENSO, and the Pacific Decadal Oscillation, PDO. ENSO events, which include El Niño and La Niña phases, cause significant climate variability on a timescale of a few years. Similarly, the PDO operates over several decades, affecting sea surface temperatures and atmospheric patterns. These oceanic cycles have profound impacts on global weather and climate, independent of human influence. Geomagnetic activity. Changes in Earth's magnetic field can also influence climate by affecting the amount of cosmic radiation that reaches the atmosphere. Variations in geomagnetic activity have been linked to changes in cloud cover and, consequently, climate. This is another natural process that demonstrates the complexity of factors influencing climate. Complexities of climate models. The reliance on climate models to predict future climate conditions is a cornerstone of the argument for human-caused climate change. However, these models have significant limitations and uncertainties that warrant scrutiny. Model limitations. Climate models are complex and incorporate numerous assumptions and approximations. They often struggle to accurately simulate natural climate variability and are highly sensitive to initial conditions. The divergence between model projections and observed climate data, particularly regarding temperature trends and regional climate changes, raises questions about their reliability. Uncertainties in feedback mechanisms. Climate models rely on assumptions about feedback mechanisms, such as the role of clouds, water vapor, and aerosols. These feedbacks are not fully understood and can lead to significant uncertainties in model projections. For example, clouds can both warm and cool the planet, depending on their type and location, making their net effect on climate difficult to quantify. Attribution studies. The attribution of climate change to human activities often relies on model simulations that compare scenarios with and without human influence. However, these studies are contingent on the accuracy of the models and the assumptions made about natural variability. The difficulty in distinguishing between natural and anthropogenic influences complicates the attribution process. Scientific dissent. While the majority of climate scientists support the view that human activities are driving recent climate change, there is a minority that questions this consensus. These scientists argue that the evidence for significant human influence is not as robust as commonly portrayed. Alternative hypotheses. Some scientists propose alternative hypotheses for observed climate changes. For example, Dr. Richard Lindzen, a prominent atmospheric physicist, has suggested that climate sensitivity to CO2 may be lower than current estimates, implying that natural variability plays a more substantial role. Critique of IPCC. The Intergovernmental Panel on Climate Change, IPCC, is often criticized for its perceived bias towards a particular viewpoint and for underestimating uncertainties. Critics argue that the IPCC's assessments may not adequately represent the full spectrum of scientific opinion on climate change. Empirical evidence. Some researchers point to empirical evidence that challenges the notion of a strong human influence on climate. For example, studies on the urban heat island effect suggest that observed temperature increases in urban areas may be due to local factors rather than global trends. Additionally, satellite data has shown discrepancies with surface temperature records, raising questions about the accuracy of long-term temperature trends. Economic and policy considerations. The argument against significant human influence on climate change also has implications for economic and policy decisions. The emphasis on reducing carbon emissions and transitioning to renewable energy sources is often justified by the need to mitigate human-caused climate change. However, if human influence is minimal, the rationale for such policies becomes less compelling. Economic costs. Policies aimed at reducing carbon emissions, such as carbon taxes and renewable energy mandates, can have significant economic costs. These costs include higher energy prices, job losses in certain industries, and reduced economic growth. If the benefits of such policies are uncertain, their implementation may not be justified. Energy security. Fossil fuels currently provide a substantial portion of global energy needs. Transitioning to renewable energy sources presents challenges in terms of reliability, storage, and infrastructure. Maintaining energy security and ensuring a stable energy supply is crucial for economic stability and development. Development priorities. For developing countries, the priority is often economic development and poverty alleviation. Imposing stringent climate policies could hinder their growth and exacerbate poverty. These countries may argue that they should be allowed to develop using affordable and reliable energy sources, as developed nations did during their industrialization. Conclusion. The argument that human activity has little to no influence on climate change is supported by historical climate patterns, natural climatic cycles, and the complexities of climate models. While this view is not without its critics, it highlights the importance of considering natural variability and the uncertainties in climate science. The debate over human-caused climate change has significant implications for policy decisions, economic development, and energy security. Ultimately, a balanced and nuanced understanding of climate change is essential for informed decision-making and effective policy implementation.